We've started looking at the inverter battery communication, and this is a continuation of yesterday's video. Now, battery management or system management, these will solely fall under solar system management or maintenance for level 3 and level 4 students. And since most of them will be working on this kind of system, this is a section of a solar PV powered system, a standalone solar PV powered system that utilizes the primitive or open loop or the channel 1 communication system. And most of them will be working on such systems. It is essential for them to understand this because during installation and maintenance, after you've done your system sizing, you should be able to also know what inverter is compatible with or what battery is compatible with what inverter, because some for this system, if you get the communication link wrong between your inverter and your battery, you risk losing your you either risk damaging the battery early enough, or you will not get maximum charging or discharge depth. Sorry, yeah, state of charges. You risk either losing the batteries early enough or never hitting the proper charge and discharge levels of the battery for its entire life cycle. And that's why it's essential for students to understand what the communication protocols are for level 3 and 4. Very important. Now, the first protocol, which is not really a protocol, if you compare it with the other two protocols, this is not necessarily a protocol. It's just it normally just relies on predetermined values being fed into the inverter, and the inverter will is just enforcing. So whether you have battery type A, B, C, D, it won't matter. The inverter will just enforce whatever you've pre-programmed it to do. So as you say, it's called either the primitive open loop or channel 1 communication protocol, depending on now the trainer or the books or the regulations they are reading. It's utilized in system with no BMS. A BMS is what is called a battery management system, and a battery management system essentially is normally placed in now in the modern batteries. We have the cells, the ones that store the charge, and then on top of them we have a small computer-like gadget that will monitor each and every particular cell. So during charging and discharging, this BMS will ensure that all the cells are charging at the same rate and discharging at the same rate to avoid that imbalance within the entire battery pack. So there's no separate data link between the charger and the battery. So between the inverter and the battery, we only have one link, that is the positive and negative cables. There's nothing else. And in modern system, as you have seen in the previous images or clips, you've seen that apart from the power cables, we can call them the power cables, there's a second set of cables that is carrying data between the inverter and the battery. But for this system, we only have two cables, the power cables, the positive and the negative cable. As we've said, it's not a protocol as such, as it relies on a set of pre-programmed fixed voltage and current limits. So what this means is that when you connect your inverter to your battery, you configure this inverter to something called a charging and a discharging profile. So what that means is that for very particular periods, either time, depending on the time of the day, the voltage coming into the inverter and the voltage of the battery and such parameters, we shall look at these charging and discharging profiles independently and how the different batteries behave. But just for a heads up, the charging profiles normally vary depending on the battery design or structure or architecture. So there are batteries that will charge if their state of charge is at 20%. For you to move them from 20% to, let's say, 80% state of charge, you need, let's say, 14.5 volts. This is just an example. Then from 80% to 100%, you'll be charging with, let's say, 12 13.8 volts. These are just examples. There's another battery design that for you to move it from 20% to 80%, you'll need probably 13.8 volts. And then once it hits 80%, moving from 80% to 100, you probably need lesser than this. So let's say 12.2 volts. And these are just examples. And then if this battery is not being discharged or it's not being utilized, you'll find that it will not maintain its state of charge at 100%. It will start discharging slowly as the chemical reactions within the battery happen. So for you to maintain it at 100% or let's say above 95%, you will need to be pushing a very small amount of voltage for you to maintain it between, let's say, 90% to 100%. So probably in this case, you'll just be pushing around 12 volts. So in this fast communication protocol, you have to get an inverter that can allow you to, it's either pre-programmed, the inverter comes pre-programmed with the battery profile. So if you just key this information, for example, you go into the inverter menu, for example, I have seen inverters with this allowance. So when you switch on your inverter, go into the battery profiles. When you select the battery type, if you select a lead, acid, gels, flooded, AGM, the inverter itself comes with some pre-programmed information. So it will know, because you as the technician have decided it's a lead acid or a gel battery, the inverter will know that between 20% and 80%, I'm supposed to be pushing 14.5 volts. Once the inverter uh, registers that the state of charge of the battery has risen from 20% to 80%, internally, the program itself will lower the charging voltage to a certain level. Once the inverter realizes that this battery is at 100% and it's not taking out any current, the inverter will know how to lower the charging voltage itself. This information is pre-programmed, and it now falls under the channel 1 communication protocol or the open loop protocol. It's not necessarily the most efficient way, because in some cases this battery could be giving wrong information to the inverter, or the inverter could be uh, picking wrong signals. The battery is okay, but the inverter is picking wrong signals from the battery, or the inverter does not have enough programs to do this charging and discharging charging and discharging management correctly. So it will not analyze the profile of the battery and do the charging and discharging correctly. So it will be either overcharging or over discharging this battery. That is the problem with this communication protocol. It's the most primitive, it's the most basic, it's the most used protocol in domestic residential systems. And for smaller systems, as we said, we don't have much to discuss here, but when now we start increasing the battery capacities for this same protocol, we shall look at how now we introduce opposite takeoffs to ensure that the inverter is reading information from the batteries all across the battery. So we shall look at these charging and discharging profiles, and then probably after that we can also look at the the installation design, so that to ensure that the inverter is reading all the information from the several batteries. After 4 batteries, you need to now change the installation design. So this system is widely practiced with these uh, categories of batteries. So we have the lead acid batteries, the gel batteries, the flooded batteries, the AGM batteries, and the unmanaged lithium batteries. So these are I think the low end category of the lithium battery technology. So they're just the lithium pack with no form of communication or an extra control gadget between the battery and the inverter to monitor the cells and everything. And we have said this is a manual setup. In some cases, you have to pre-program all this information to the inverter. In some cases, the inverter has got like half of the program. So you just have to input the other half, and the other half just probably means like the time you want the batteries to charge. For example, if you want your batteries to charge within a 6-hour window, you can input that information. There are inverters, advanced inverters that have got that provision. If you want your inverter to charge probably using the sun during the day, and charge also with the KPLC during the night, that is in case the 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 sun did not charge the batteries enough during the day, but there's KPLC or grid available, the inverter can read the state of charge, not the charge. Yeah, okay, it can determine the voltage in the batteries. If it's not high enough and there's no available sun, the inverter can automatically pick from KPLC and keep charging the batteries. So you have to manually input all this data into the inverter and let it now determine what to do. So in most cases, the low-end inverters will not have all that provision, but it's just good for you to learn and understand as early enough. So in this system, the inverter has no idea of the state of charge. That is one thing you have to remember. In this system, the inverter will only read the battery voltage. It will never be, it will never determine the state of charge of that battery. The internal temperature, so the inverter and the battery's temperature will never be communicated to the inverter. And this temperature, we said, is important because most of these battery technologies behave differently under different temperatures. So in our previous sessions, we've said if the temperature is too high or too low, it will affect the charging and discharging profile of the battery. But in this system, the inverter will never be exposed to the battery's internal temperature and health of the individual cells. Now, as you know, a 12-volt battery or a 24-volt battery is a pack. Inside that pack, we have got individual cells. So in this system, the inverter will just know the voltage across the battery pack. It will never be able to determine the individual health of the cells or the voltage of the individual cells or the state of charge of each and every individual cell. A brief example of what I was saying, the charging or discharging profiles. We have got the bulk or the absorption voltage. Now, in this first system, once you've connected your inverter to your battery and you've told your inverter that this battery is this type, for example, this is a lead acid battery or this is a lithium ion battery. Once you've told that to your inverter, and as I have said, some inverters have got an already existing program. So what you as a technician just has to define or to determine the battery and tell the inverter this is the type of battery that you're supposed to charge. So the inverter itself will know the bulk or the absorption voltage that it will be pushing to the battery. And this is the high voltage for the charging phase. And I had explained that the charging phase is probably when you can it might come pre-programmed, or you can adjust the program if the inverter allows you. So this means, for example, you want to lift the battery, let's say in a charging cycle, early one morning, the battery is at 20%, and you want to lift it all the way to 100%. So we've got stages. It will come from 20% probably to 80%, then to 100%. This is not a fixed design. These designs do vary. This is just an example. So the bulk or the absorption voltage will be utilized here between 20 to 80%, and it's normally a high voltage. The inverter will push a high voltage into the battery. And then once the inverter determines that this battery is at a certain voltage, it lowers the amount of voltage now that it will be pushing into the battery. And that will be from 80 to 100. It lowers the voltage to lower now the speed, the charging speed. And you can also pre-program this to happen even using the daily sun hour behaviors. So you can either determine it, you can either decide So some inverters can decide this to happen either pre-programmed, or they can allow you to program that setting so that this bulk or absorption voltage phase happens between 9 p.m. and let's say 1 p.m. Not 9 p.m., 9 a.m. and 1 p.m. And then from 1 p.m., whatever state the battery is, you shift. These are just examples. They are not set behaviors or set programs in an inverter. I'm just giving you an example for you to understand how inverters behave. The float voltage, this one keeps the battery full after charging is complete. So for example, the float voltage can kick in at probably 95% or 90%, depending on the battery design, the inverter design, or you, the technician, preference. So once the battery reaches 90%, the inverter lowers the voltage that it will be pushing into the battery, so that this battery can hit 100, and then it will not stay at 100, of course. So if there's enough sun and there's no load and everything, and depending on various other parameters or aspects, the inverter will keep pushing a very small amount of voltage, probably in single bursts or in a continuous burst. It depends with the design of the inverter, the manufacturer, and the battery. And that is called the float voltage. And then there's what we call a low voltage disconnect. This is the minimum battery voltage before the inverter disconnects. So in this case, for a standalone system, if you do not have a second source of charging or a second source of power, once you've drained your battery, let's say you can program your inverter to determine that once the battery is at 20% and you don't want to punish your batteries any further, you just disconnect, the whole system goes off. So that's a low voltage disconnect. You can pre-program it. It might come pre-programmed with the inverter, or you can program it yourself. You can even lift this percentage to 50%. So once the inverter determines that the batteries are at 50%, it cuts off power, or it shuts down to protect your batteries. And this is essential for specific battery types. For example, for lead acid batteries, do not allow them to be discharged below 50%. So if you've connected your battery to your inverter and you've told your inverter that this is a lead acid battery, the inverter will, if it has been pre-programmed, immediately you've discharged your batteries to 50%, the inverter cuts off power. So it will force you to either get a second source of power or an alternative to now allow the inverter to keep charging the battery. If it's beyond, if it's gotten to 50%, the inverter will have to now start again charging the battery, probably now from a second source if solar is not available. So that is just a brief introduction to charging profiles, and we can also look at it deeply depending on the battery category. And it's essential to know this because when you are linking your inverter to your battery, always ensure that you find an inverter that has got provisions for you to determine what battery it's going to charge. There are some inverters that are so primitive that they will not allow you to, like the inverter is just like a block. It is picking power from the panels. It's converting, like it has got all inbuilt components, and they've been landlocked, leaving you as a technician or as a user with no option of changing these parameters. And that will be bad because the battery structure or architecture might suffer if the inverter was programmed to charge one category of batteries. So for example, if the inverter has been built to charge gel batteries and you are linking it to a lead acid battery, if the parameters, if the pre-programmed inverter parameters are a bit off or way off, over time you'll see that your batteries are suffering, not because you are over exploiting them, but because the inverter is not maintaining a proper charge and discharge profile for that particular battery. So it's essential for students to understand the role of this communication protocol in primitive systems. So I hope I've given you a proper brief introduction of the first communication protocol, and For level 3 and level 4, I don't want to go into the CAN bus protocol or the other digital protocol, the RS protocol for now. For the level 3 and level 4 students, after learning this protocol, we shall look at it further and see some of the advantages, some of the disadvantages of it. One of the advantages is that it's cheap. Basically, the accessories for this system that can rely on this protocol, they're some of the most basic, the entry level products. So, but we have got also the disadvantages, and one of the main disadvantages that apart from the voltage, the inverter and the battery do not communicate on any other parameter. So temperature, state of charge, all that, the inverter will never know. Now, we shall look at ways of ensuring that the communication between an inverter and a battery is well developed for this particular protocol, and how to configure your system to ensure that the inverter and the batteries are communicating the best way they can. Let me try and make a few requests to brands. Okay, most brands are not normally open to share this information, but I'll try. Whoever will respond, well and good. So let me try and make a few requests. Let's see if there's a brand that is willing to show us their inverter and how they set these communication protocols. If I won't manage, it's okay. We shall learn. If I land on it in future, I'm saving these videos on TikTok and YouTube. We shall be referencing them in future for learning purposes. So if I land on an inverter that has got this first protocol and allows you to enter extra programming information, I'll share and I'll tag the video. So for students who are at level 3 and level 4, go over this video over and over, listen in. If you have a question, kindly ask. And massive thanks to cable experts for having given us this display board. I don't know if they have got a catalog for the DC side between the solar and the inverter. I'll have to inquire, but when we come to AC installations or the electrical side, we shall be referencing some of these cables and showing you where they can be utilized on this board or on this learning softboard. Thank you very much. And remember, you can also help us by subscribing to the channel, YouTube channel. You can share, you can follow where there's an option of following. You can, just interact with our work and share it, like, share. You can ask a question if you want. If you have a particular question, even if it's not related to this particular topic, we can also look at it with you. Thank you.